Hey everybody, it's Mr. Oaks. I'm going to be talking to you today, there we go, about probability and statistics. So what probability is the likelihood that something is going to happen given certain conditions. So what we're going to start off with today is we're going to talk about frequency tables and then how we can use basically what's called a relative frequency table in order to figure out the probability of something happening and how we would go about that. So what I have here is I have a frequency table, and basically what a frequency table is it's a table that allows us to see how many times something happens and then be able to compare that. So what I have here is complete the frequency table for the following set of data, and then we have all these numbers here, okay? And what we did is we broke it up into intervals. Interval is just a range that we give for where we want things to kind of fall into a category. We could do these frequency tables with different categories like different colors. We could do them for individual numbers. We could do it for hair color, eye color, gender, anything like that. Basically any category that we see, we can just kind of see, well, how many things fall into this category, how many things fall into that category. And that's what a frequency table allows us to do. So this is the intervals. We got 0 to 4, 5 to 9, 10 to 14, 15 to 19. Now obviously these intervals, what the data has to be able to fit into those intervals. So we don't want to, if we see that our highest number is like a 15, we don't want to stop our intervals at like 10. Because that would be good. We won't have all the data included. So we have to make sure that we include values that cover all the data. Tally is just, we're going to basically make little lines to basically check off. We got one that fits in this category, and we got another one that fits in this category. We're just going to keep marking it off. And the frequency itself is when we're going to count up those tallies and see, well, how many did we have? So it's actually relatively simple. So what we're going to do is we're going to go one number at a time, and each time we mark a number, we're going to mark it with a tally and make sure to cross it off, because you don't want to count something more than once. So you want to make sure that you're keeping track. It's very important that you pay attention and you keep track by crossing out and making sure that you've made sure to go and do every number once and only once. So the first number we have is a 9. So what I'm going to do, I see it's in 5 to 9, so I'm going to put a tally mark. And you see it looks like a 1, but it's just a little line to mark off that I did the 9. The next one is 16. Okay, so that goes down here. 0. 19. So now you see I've got 2 lines, so that's telling me there's 2 things that fit in this category. Okay, mark that off. 10, 5, 0, here, 18, 1, 16, 6, 18. Now what I'm going to do is I have 4 tally marks here. What I do is I draw a line across them to show that now I have 5. Okay? 8. Another 8. There's our little cross. 19. So now I'm going to start another set of 5. 17. Actually, 10. 14, 9, 1, 16. And so now all I'm going to do is I'm going to count up the number of tallies I have and write down the actual number. So from 0 to 4, I have 1, 2, 3, 4 tally marks. So I'm going to write down 4. 5 to 9, I have, this is 5, I have 6. Here I have 3. Here I have 5 plus another 3, so that's 8. So if I wanted to see, well, how many do I have in total? I have 10, 13, I have 21 in total. Now, using that, I could kind of start to use that total, that 21, and then start to use these, kind of make a prediction of, well, if I was to choose a number randomly from this group, what was the likelihood that I would pick a certain number within a certain range, okay? So if I was like, oh, well, what's the likelihood that I would choose a number between 5 and 9? Well, there's 6 numbers out of 21, so I have a 6 out of 21 chance of choosing some number between 5 to 9. And that's basically what probability is. Okay, is a comparison, or what's the likelihood of something happening. So, what I can then do is make what's called a two-way table. Okay, so maybe I have two things that I'm looking at. You know, students in a classroom, and I have information, and I want to know, well, you know, how many students have chores and how many don't. And maybe then I break it down also by gender. So I say, well, here's the boys, here's the girls. And so I mark down those two categories. And what a two-way table does is it takes those two categories and makes it see, well, we have the boys, we have the girls. Well, how many boys have chores? How many boys don't have chores? How many girls have chores? How many girls don't have chores? And then we can use that to figure out the likelihood of, well, what's the likelihood that if we just chose a student at random, that we would choose a girl that has chores, or a boy that doesn't have chores? Or what's the likelihood that we're just going to choose a boy? Or what's the likelihood that we're going to choose someone who doesn't have chores? So we have these different probabilities that we can have. So when we have something that is kind of involves just one group, like boys, that's known as a marginal frequency or a marginal probability, because we're really only dealing with one category. But we can also have it where they have both categories. So like, what's the likelihood out of the entire group that we're going to choose boys that have chores? Okay, so those are two different types of probability and frequency that we can do. So when we look here, we have in a class of students, the following data table summarizes how many students play an instrument or a sport. So if we look, so going across, going horizontally, we have the sports. The top one is those who play a sport, the bottom is those who don't. Vertically, we have the instrument. Plays an instrument, does not play an instrument. If you look, we don't actually have a total for any of the columns, any of the rows, or just for all the information in total. So what we can do is we can add those. So I'm going to put a total over here. And I'm going to put a total over here along the bottom. And what we'll do is we'll find out, we'll add up across, we'll add up down, and then we'll figure out, well, how many are there in total. So I'm going to start with plays an instrument. So we have here 5 and here 4. 5 plus 4, so 9. So we have 9 students in total who play an instrument. Here, 2 and 12 gives us 14. So in this total group, we have 14 students who don't play an instrument. Then we can go across. Plays a sport, 5 and 2. So 5 plus 2, we have 7 students who play a sport. Does not play a sport, 4 plus 12, 16 students that do not play a sport. Well, the last thing we're going to do is we're going to figure out how many students are there in total. The way we make sure that everything's working out right is we're going to make sure we're going to actually add up and down, and we're going to add side to side. We should get the same number. If we don't, then we made a mistake somewhere. Okay? So I have here 7 plus 16 is 23. So if I add across, 9 plus 14 is also 23. So we had 23 students in total who were surveyed in this class. Well, then we come to our question, which is, what is the probability that a student plays a sport or an instrument? So we're not being asked, oh, how many students play, what's the probability that a student that plays a sport? That would be 7 out of 23. Does not play a sport? 16 out of 23. Oh, how about if they just play an instrument? 9 out of 23. Does not play an instrument? 14 out of 23. Now, 23 doesn't have anything nice that goes into it, but it's usually preferred that you simplify. So you'll wind up with a fraction, but you do want to simplify if you can. So if I had, say, 6 out of 24, well, 6 goes nicely into 24. So I would divide both by 6. And I would actually write the probability is 1 over 4, or 1 out of 4. There's a 1 out of 4 chance that you would choose whatever that was. In this case, since it's 23, 23 is a prime number, only 1 and 23 go into it, so anything we put on top that's what it is, okay? So what this asks, though, is what is the probability that a student plays a sport or an instrument? So what we have to do, that or means they could just play a sport, they could just play an instrument, or they could play both. They could do both. They could play a sport and an instrument. So there's 3 different things we have to take into account. So what I'm going to do is I'm going to go and my total population, 23, this right here, 23. I'm going to put that on in my denominator. Okay? I'm going to kind of make a long thing, and 23 is going to go on the bottom. All right? Because that's my total. Out of everything I could have, there's 23 things. Okay? There's 23 students that was in my population that I could choose from. And then what I'm going to do is I'm going to go, well, okay, well, how many students play an instrument but not a sport? So here's plays an instrument, and here's does not play a sport. That's 4. So I have 4 students there. How many students play a sport but don't play an instrument? Plays a sport, does not play an instrument, 2. So I'm going to do 4 plus 2. And then lastly, since it can be or, they can play a sport, or they could play an instrument, or they could play both. Plays an instrument, plays a sport, that's 5. So I'm going to add 5. So when I do that, nothing changes on the bottom. I'm still left with 23. 4 plus 2 is 6, plus 5 is 11. I'm not going to change it to a decimal because I want it to be exact. Fractions are exact values. When you change it to a decimal, there's a possibility that you get a repeating decimal or a decimal that just doesn't end. Anything you do with that, once you cut it off, it's an approximation. We want exact values. That's why this fraction is our answer, 11 out of 23. Okay? And that's how we do probability. I hope everybody is well. Stay safe, stay healthy. Bye.